Welcome back. Hopefully you've already watched the videos that came before this that talked about things like forming a hypothesis statement, writing an introduction, writing a materials and methods section. Today's video is going to focus on writing a results section. How do you present your results in a scientific paper or a laboratory report? By way of introduction, or not introduction, actually review, where do you start? Well, your laboratory report should start with an introduction. And as I've said before, primarily this should be a literature review. You should review what research has gone before, what the findings were, why it's worthwhile doing the research you did, and what is your hypothesis statement? What is your research goal? So these types of things would occur in your introduction. All the backgrounds that the reader needs to understand what you're going to be talking about. They need to know the actual purpose. What was the goal? What was the objective of your research or of your experiment? And they need to know very, very clearly your hypothesis. And if your research did not have a true hypothesis, then what was the purpose in very clear terms? All of these things come together as your introduction. So that's one part, the first major part of your lab report or your paper. What's the second part? Well, the second part, the second section, will be your materials and methods section. And as I've mentioned before, that will be a sentence and paragraph style presentation of what you did. So how was the research performed? So the introduction gives the background, the materials and methods gives the procedure, the ingredients and the procedure, and then comes the results section, which I'll be focusing on today. What goes in a results section? Well, I'll be talking about that as this video goes on, but oftentimes, particularly for laboratory reports, it will involve creating some tables and some figures in order to support your paragraphs that tell the reader what your results are. After the results section, there will be another section, and that's the discussion section, which is different than the results. There are some similarities, but there are differences. We'll talk about discussion in a separate video. And as I've mentioned before, any research that you refer to needs to be mentioned in your reference list, sometimes just called the references or the cited literature. So let's go on to the results section. So what's the goal? What is the purpose of a results section? Well, your goal is to present all of the relevant results. Now, this is an important word, relevant. All the relevant results that a reader might be interested in knowing. And what should you focus on? Well, you should focus on the most important results. So those are known as the key results. So you focus on the key results, but you provide more than that. So all the results that the reader might want to know, but focusing on the key results. Now, it's very important to remember that this is a written report. That means it's written form. That means sentences and paragraphs. So always use written form. Carefully design your paragraphs to convey the information to the reader. Now, in the case of a results section, it can be very, very helpful to also use visual forms. So to create a table, rows and columns that present data to the reader, or usually better, a figure like a graph that shows the data that was collected, the results that were obtained. So it'll depend on what your experiment or research involved. Maybe you'll have no tables or figures. But usually, particularly in a classroom situation with a laboratory report, there'll probably be a table or, more likely, one or more figures. Just remember that in the results section, you need to describe what you found. So it's not a matter of coming up with the perfect figure and then thinking, oh, I don't have to write a paragraph. You still have to write many paragraphs for your results section, but you're going to supplement that information with figures, with tables. So your goal in your results section is to summarize the findings from your research and to do so objectively. Now, that's really, really important. It's supposed to be objective. So it doesn't matter how excited you are about your findings or how sad you are because all the answers were wrong. That doesn't matter. Be objective. Just say, you know, this is what was done and this is what the result was. Be objective. Now, as you're writing your results section, what should you be thinking of? Well, in terms of your verb tenses, most likely you're going to be using past tense. Why? Because you're presenting your results from the research you previously did. You did it that morning, the day before, a week before, a month before, but it's in the past. You did the research, and the results section presents what you found, past tense. So make sure you objectively present things, and most likely you'll be almost entirely using past tenses. Another one, very important one, a little bit strange, but it's a case for scientific writing in English, is you are not supposed to use the first person. You're not supposed to say, I did something, or we did something. And similarly, the reverse, you. Okay, you're not supposed to use that in scientific writing. Other words, my, your, our. These types of words, we're not supposed to use them in modern English scientific writing. Notice that this is actually a scientific writing issue. In normal written English, it's perfectly fine to use first person, and in fact, there's a preference for it. However, in scientific English writing, in modern scientific writing, we're not supposed to use these words anymore. So what do? If you want to explain what you did? Naturally, you would say I, and then explain what you did. That's how you'd say it out loud. It's what you would write if it was not scientific writing. What should you do? Well, the answer is passive voice. You want to convert those sentences or write those sentences in passive voice. So don't say, I collected the data. Say, the data were collected. Okay? Go to a passive voice approach to presenting your findings in order to avoid using I, we, you, our, my, these types of words. Let's take a look at an example. The purpose of this experiment is to observe the conservation of momentum and energy in a real-life setting. We will study this concept through the motion of toy cars colliding on a track. Colliding is crashing into each other. The speed of the cars will be determined before and after their collision. Okay, so are there any problems here with this writing? Could this be part of a scientific report? Well, actually, there are a number of problems. The purpose of the experiment is to. This is not a past tense thing, so we've got a problem there. We will study. Okay, so we've got a problem. It's using the word we. We should not be there. Okay, so we've got a couple problems with the tenses, will be, so we've got a future there that probably should be past. Let's take a look at a corrected version. The purpose of this experiment was to observe the conservation of momentum and energy in a real-life setting. Notice that it doesn't matter if the research was successful or not. Whether it was successful or unsuccessful, the purpose was to observe the conservation of momentum and energy in a real-life setting. The other writing will let us know if it was successful or not, but this was the purpose, okay? This concept was studied, not we will study. Passive voice. This concept was studied through the motion of toy cars colliding on a track. The speed of the cars was determined. Remember, it's a results section. You've already done the research when you're writing this, so this should be in past tense. The speed of the cars was determined before and after their collision. So when you are writing your results section, almost always you'll be in past tense, and although it may feel natural to say I or we, you need to change that approach to using passive voice when doing scientific writing. There are other things you should think about when you're writing your results section. For example, tables and figures. Should you use them? And if so, how? And what should you be thinking about when you are including these types of things? And what is a table and what is a figure? And are there other options that you also might want to consider? Well, another option you might want to consider is a diagram. So a diagram showing the reader, what you did or how you did it, your experimental setup. In fact, a diagram might be a really nice thing to include in your materials and methods section, or even a photograph. When you're doing your research, take a picture of your experimental setup and then include that in your report. So you might sometimes have diagrams, you might sometimes have photographs, but for the most part, in most reports, it will be either a table or a graph. Well, in scientific speech, in the way we talk in science, generally we think of tables and figures, where a figure is, well, any visual thing that's not a table. So usually, even if we have a diagram, we call it a figure. Even if we have a photograph, we call it a figure. And of course, if we have a graph, a plot of some data, we call it a figure. It's not necessarily wrong to use the terms diagram or the term photograph if that's what it is, but it's more common to just refer to them as figures. So just be aware that tables and figures are usually the terms and the things that we use. So what are these? You probably already know a table. It arranges information in rows and columns. So if it's something that would look like a spreadsheet, okay, that's almost certainly going to be a table. A figure, as I've already mentioned, could be a diagram, could be a photograph, but most commonly it will be a graph. So data is plotted on X and Y axes, for example. This is the most common type of figure. So why would you use tables and figures? Well, you'd use them when you have a lot of data to present. If you need to present 100 numbers to your reader probably doesn't want to read that in sentence form. So a table might make more sense, or a graph might make more sense. So when you have a large amount of data, these types of things, tables and figures, can be helpful. And in particular, if you want to be comparing two different things, you collected two sets of data, and you want to compare them and show your reader the differences. Well, showing the differences, boy, you know, probably a figure is going to be the best way of doing this. But in any case, use tables and figures to present your data in a way that's easy for the reader to understand. Now, a few details about formatting and such. If you only have one table, you do not have to give it a number. You can just say the table. If you only have one figure, similarly, you do not have to number it. But if you have more than one, you need to number them. So you number them from 1, and tables and figures are numbered separately. So you might have table 1 and then figure 1. And then you might have figure 2 and figure 3 and table 2, and so on. So you number from 1 for the tables. You also number from 1 for the figures. Now, as far as the order, always start with 1, the first one mentioned in your report. That's the first table mentioned is table 1. So always make sure they're in the proper order. Also, make sure that somewhere in your paragraphs, somewhere in your sentences, you tell the reader when they should be going to look at the table or the figure. Every table or figure must be mentioned at least once in your paragraphs. And it can be something very simple. So it can be something like, figure 3 presents the data from the 3rd trial. Okay? Well, you've just mentioned figure 3. It's now been mentioned. It has to be mentioned at least once. You could also describe your key results and then in parentheses say, see table 1. So again, somewhere in the paragraphs, somewhere in the sentences, even in parentheses is okay, there's a reference to the table or the figure. If you forget to do this, what happens is a reader is reading your paragraphs and they literally skip over your tables and figures, turn the page and forget that they're there. You need to let the reader know, you should go look now. But instead of saying go look now, you just say, you know, the data is presented in figure 2. So you have to mention it though. You must mention every table, you must mention every figure at least once. As far as the actual presentation of the tables and figures go, they all should have a title. Preferably short, but it should be very clear, and importantly, it should be informative. So a really bad title would be the results. Okay, that would be a really bad title. The measurements, again, that would be a really horrible title. You need to let the reader know what is in that table or what is in that figure. So give descriptive information in the title. It could be short, 3 or 4 words is often enough. And if it takes 10 words, it takes 10 words. But be clear so that the reader looks at the title and they know what the information is about. If you're creating a table that's going to be arranged in columns and rows, every column must have a heading. So if there's information in a column, The very top row must contain a heading, a description of what's below it. Usually, you will also have headings on the left side for every row, but it depends precisely on what it is you're doing. But at least every column should have a heading at the top. For figures, if it's a graph, then the axes, the x-axis and the y-axis, for example, need to be labeled. Don't assume that your reader will figure out what they are. You need to tell them. There needs to be a label for every axis, letting your reader know what is being plotted. And don't forget the units. Sometimes people plot their data, they've been working with it for weeks, so they know they're measuring things in grams, and they create a figure that shows something, but they don't mention that it's measured in grams. Well, the reader might not know that you measured things in grams. So your title might mention that it deals with weight, so they know it's about weight. They see numbers, but they don't know, are these milligrams, grams, kilograms? They don't know. So make sure that all numbers have clear units indicated. So put titles for your axes and make sure the units that you're using are clear. Another thing is to be consistent. So if you're only creating one figure, you don't need to worry so much about this. But if you're doing 2 figures or 3 figures and they're similar, make sure that you're consistent in your presentation. So use the same labels. Use the same axis labels if they are in fact the same. Use the same units if possible, if it makes sense. Use the same intervals. So for example, I've seen people do 2 graphs and one of them, they went for, the x-axis was labeled 0, 1, 2, 3, 4, 5. And then another similar graph was presented where the labels were 0, 2, 4, 6. So the labeling was inconsistent. That confuses people when they're reading your material. So make sure you're as consistent as possible across your tables and figures. Now, where do you put your tables and figures? If you're a scientist and you're publishing in a journal article, the editors will actually figure it out for you. They will, in fact, it's not just they'll figure it out for you, they will decide. It doesn't matter where you want it, they put it where they want. But if you're doing a laboratory report, you need to choose where to put it. So publishers put it wherever they think is most appropriate. But if for a laboratory report, there are a couple of options. Usually the easiest is to put it at the top of the page where it's mentioned, or to put it immediately after the paragraph that first mentions it. So if a particular paragraph mentions figure 3, and that's the first mention, after that paragraph, you'd actually put figure 3. So not necessarily the top or the bottom of the page, but after the paragraph where it is first mentioned. That would be the standard way of going about it. It usually looks nicer if they're at the top or maybe the bottom of the page, but the reality is that using a word processor, it's very difficult to put them there and have everything look nice. And then you find a mistake later when you're proofreading your report and you fix that error, and suddenly, even though the error was on page 1, the figure on page 3 suddenly looks funny. Weird things happen. So it's usually easier to just put it after the paragraph where it is first mentioned. So that's what I recommend you do unless you've been told something else. Now, a few things to think about. The tables and the figures supplement the paragraphs. You present your results, your key results, in paragraph form, and then you give a little bit more, a little extra, a visual presentation of them using the tables and the figures. Okay? So you need to think about how the words and the pictures work together, the words and the figures. So let's say you're writing a results section, and let's say you had this graph. So 2 curves are there, and you're going to describe these 2 curves to your reader in paragraph form. So somewhere you're going to have a sentence that compares them or contrasts them. What would you write? Well, let's say you wrote, as can be seen in the figure, the 2 curves are very similar. Well, that word choice, you have told your reader they're similar. So the reader is going to focus on the similarity between the curves. They're going to be thinking about the similarities. So if that's your goal, That's great, that's what you should do. But if your goal is to point out that, well, even though they're similar, in fact, there's an important difference, maybe you should write something like, as can be seen in the figure, the two curves are noticeably different. So both of these sentences could be used to describe that figure. But one of them focuses on similarities, whereas the other focuses the reader on the difference between them. So when you're presenting your results, do think about what is it you're trying to convey. If you want the reader to focus on the similarities or the difference, pick the words in your paragraphs, in your sentences, to guide them appropriately. The comments you make help your reader. At least they're supposed to help the reader. Write your paragraphs to help your reader understand what they're looking at and what it means. A few things to avoid. Presenting too much data, presenting too much detail. I've seen sometimes laboratory reports from students where their experiment involved measuring a few things, so measuring 3 things, taking those numbers, putting them in an equation to calculate a value, and then repeating that 50 times. Nobody wants to see all 50 of the first measurements and all 50 of the second measurements and all 50 of the third measurements, as well as all 50 of the calculated values. Nobody probably will want to see all of that. As the experimenter needs to look at it, needs to make use of that information. But your report, you're supposed to present the key results as well as anything the reader needs or probably wants. So would they want the intermediate values, the things that you measured before the final calculation? Probably not. So probably that should not even be presented. So think about what should you include and what should you omit. If a lot of data does need to be presented, occasionally it does, then use a figure if it will be easy to understand. If the figure will not be easy to understand, then use a table. In general, figures are easiest to understand, followed by tables, followed by very long paragraphs. So you want your paragraphs to not be overly short, but you want them to be clear and easy to understand and supported with tables or figures to the degree that it helps. Now, because of this, some people say, oh, well, the figures help. They're easier to understand. The tables help. They're clearer. And what they end up doing is overusing the tables and figures. So this is similar, but it's a little different than presenting too much data. What should go in the paragraphs? What should go in the tables and figures? You need to give thought to this. Make sure all the key information's in the paragraphs, and then in your tables and figures, the key information plus. Okay, but not excessively. But when you do that, do not overuse tables and figures. Do not think that you can, oh, I'll just have 5 figures and 1 sentence as my results section. That'll be a very bad results section. You need to be writing paragraphs supported by tables and figures. So make sure all your key results appear in your paragraphs, and make sure that it's written clearly so that your reader can just read the paragraphs and know what your key results are. Use the tables, use the figures to give extra information and to add even more clarity. Another thing to watch out for is presenting the same data in multiple places. Occasionally, this is appropriate, but occasionally it's just unnecessary redundancy. So your key results must be in the paragraphs, but they're probably also going to be in your figures. That's okay. But for minor information that most readers will not want, probably you don't put it in both places, just one or the other. So do think about, should this be mentioned only once, or should it go in more than one place? So give that thought, avoid excess duplication, pick a figure if that will visually help the reader more than a table. If it won't, consider a table for giving a lot of data rather than writing it out in lots and lots and lots of long sentences. But remember the key results. The key results must be in the paragraphs. Okay, let's take a look at what you might think of as a problematic sentence presentation. So let's take a look at an example here of something that would be bad. Okay, so imagine somebody wrote, quote, the densities of the product, density is, how tightly packed things are. The densities of the products were recorded and found to be 1.221 grams per milliliter, 1.1082 grams per milliliter, 1.2128 grams per milliliter, 1.0583 grams per milliliter, 0.970107 grams per milliliter, 1.3641 grams per milliliter, 1.4955 grams per milliliter, 1.2429 grams per milliliter, 1.58 grams per milliliter, and 1.2333 grams per milliliter. The average was 1.22961 grams per milliliter, and the 95% confidence interval was plus or minus 0.30997652 grams per milliliter. Now, if you found my presentation reading you that sentence extremely boring, good, it was. It was horrible. This should not be written in a report. Nobody's going to want to see this in sentence form. We have way too much detail. Okay? Now, if these numbers are really needed, maybe a table, maybe a graph, but not in sentence form. And also notice the inconsistency. So the first number given, 1.221, there's 3 positions past the decimal point. But on the last one, 1.23333, there's 5 positions past the decimal point being given. Consistency is critical in scientific writing. So figure out what is the appropriate number of digits for how carefully you measured things, and give that number of digits for everything. Don't sometimes use 2 and sometimes use 5. And oh my goodness, the confidence interval has 2, 4, 6, 8 digits. Did you really calculate so accurately that that 8th digit after the decimal place is accurate? Probably not. So this is a very big problem. Do not do this. Do not do this, okay? Now, what might you write? Well, some of this detail might go in a figure or a table, and then just write the key results, the key information. For example, the average density of the product, based on 10 repeated measurements, was determined to be approximately 1.2 grams per milliliter. Isn't that a lot clearer? Much, much clearer. It's nice and short, it's easy to read, and if the reader wants more detail, they can look at your table or your figures in order to get more detail. But most likely, if you're heading for an average measurement, they want to know typically, what is the measurement, they're not going to care about the 10 separate measurements. They'll only want to know the average. Maybe they'll want to know the highest and the lowest and the average. Maybe they'll want a confidence interval, maybe not. You need to give thought to what is the best information to give, but you do not want to be doing something that should be done in a table in your sentences. So think about, should it be in the sentences? If it's key information, it must be in the sentences, in the paragraphs. And then if it's other stuff the reader might want or maybe should know, think table or figure for that extra information. So I hope this is helpful for you. Do think carefully about presenting your results. Remember, be objective. No excitement that you're happy that you found the right answer or that you're very sad and you're confused because all the numbers were wrong, not what you expected. Don't worry about if you were right or wrong, if your hypothesis was supported or falsified. Don't worry about that when you're writing a results section. Figure out what are the key measurements, what are the key findings, organize them into nice sentences and paragraphs, and then think about what other information might your reader want or need, and create either a table or figures. Usually figures are better, but figure out tables or figures and provide that information in figures and tables and work that into your paragraphs to see table 3, see figure 2, and so on. And remember to be consistent in how you approach things. So use the same intervals for your x-axes and your y-axes if they're measuring the same thing. Be consistent throughout scientific writing. Hope this video is helpful for you.